Hi, this is Mrs. Kidman, and in this video, we are going to be discussing how we can prove that a quadrilateral is a parallelogram. So when we're proving that the quadrilateral is a parallelogram, what we can do is there are 5 different things that we can look at. We can either show that both pairs of opposite sides are parallel. We can show that both pairs of opposite sides are congruent. We can show that both pairs of opposite sides and angles are congruent, show that one pair of opposite sides is congruent and parallel, so that has to be the same pair, or show that the diagonals bisect one another. So using each of these 5 things, what we're going to do is I'm just going to run through some examples, and we're going to list which of these reasons tells us that these quadrilaterals are parallelograms. So let's take a look at this first one here. So this one has A and C are congruent and B and D are congruent. So how do we know that this is a parallelogram? Well, that's because the opposite angles are congruent. And knowing that both opposite angles are congruent, that proves that those are congruent. Now let's take a look at this one here. You can see that this part of the diagonal, this diagonal here is bisected. And this diagonal is bisected. So based on the fact that the diagonals are bisected, the diagonals are bisected or split into 2 equal parts, that tells us that this quadrilateral is a parallelogram. Do you kind of see what we're doing here? So we are going to take a look at a couple more examples where we just kind of run through these, and then we will let you go and practice proving it on your own. So let's take a look at this one here. So again, this one has 4 angles that it's given to us. Because these are both equal, we know that these are congruent to one another, and this one is congruent to that one. So because both pairs of opposite angles are congruent, that means that this is a parallelogram. Awesome. Okay, now let's take a look at this one. Ooh, we can see that this is 20 and this is 20 and this is 14 and this is 14. Remember, if things are the same length and the same shape, then they're congruent. So we have the pairs of opposite sides are both congruent. And that is one of our things that tells us that a quadrilateral is a parallelogram if the opposite sides are congruent. Okay, let's take a look at 2 more here. So this one right here, this one also tells us that it's congruent. The reason why is because this is that 1-in-1 where it says the opposite sides are congruent and they're also parallel to each other. So because the opposite side is congruent and the opposite side is parallel, and these are both talking about the same side, that actually implies that this has to be a parallelogram. How cool is that? So the very last 2 that we're going to look a little bit more in depth of what we can do here. So let's take a look at this one first. So this one doesn't tell us the specific things that we needed. Like before, we were given 4 angles or 4 sides or the sides that are parallel. But what we want to do here with this parallelogram is show that this parallelogram is, or this potential parallelogram, this quadrilateral, is a parallelogram. That's really what we want to do. Show this quadrilateral is a parallelogram. The way that we're going to do it is we want to choose kind of an option of what we can do. We can either show that all the angles are congruent, all the sides are congruent. It's kind of up to you. What I'm going to do is I'm going to show that all the sides are congruent. The reason why is because I know that this side is the same as this side and this angle is the same as this angle. I also know that this diagonal piece here is the same as itself. So what that means is triangle ABC, or not ABC, triangle ABD is going to be congruent to triangle CDB by side, angle, side, because you can see that this side, this angle, and this side is congruent to this side, this angle, and this side. Because of that, that means our triangles are congruent. And if our triangles are congruent, that means that AB is going to be congruent to CD. And if those 2 pieces are congruent, and that's going to be by that corresponding parts of congruent triangles are congruent theorem. If that happens, then both pairs of opposite sides are congruent. Sorry, I can't talk and write at the same time. Are congruent, and that implies that this is a parallelogram. Awesome. Okay, we've got one more that we're going to look at here. It's going to be more similar to this one. So in this case, we have a beautiful quadrilateral here, and we want to show that it's a parallelogram. Well, I'm going to do something similar to what I did last time. I know that this angle is the same as this angle. I know that the green angle is the same as the green angle. I also know that this piece in the middle, this diagonal, is going to be the same as itself. Now, because those are going to be the same, what that means is that this triangle that is created here, so triangle ABD, is actually going to be congruent to triangle CDB by the angle side angle congruence theorem. Okay, what that tells us is that this triangle is the same as this triangle here. And if we know that those two triangles are the same, what that actually tells us is that means that there's kind of two things we can get from this. It either means that we can say that angle A is congruent to angle C, which is by that corresponding parts of congruent triangles are congruent. And then using that, we can say that angle ABD plus angle CBD equals angle B. And we can say that the measure of those angles, sorry, let's be precise here. And we can say that the measure of angle, so let's see, ABD equals that. We can also say that the measure of angle CDA plus the measure of angle, sorry, I'm getting my letters mixed up here, ADB is equal to the measure of angle D. And if those are equal, we know that this is the same as this, and this is the same as this. So because of that, I can actually rewrite B as being the same as this by the substitution property. So that means that the measure of angle B is actually equal to the same thing as the measure of angle D, so CDA plus the measure of ADB. And then using substitution or the transitive property, it's up to you, we can show that the measure of B is equal to the measure of D. And lastly, I can then show that those are congruent. So angle B is congruent, well, that's not a curly line, to angle D. So if these two are congruent and these two are congruent, then those are congruent. We could, that's proving with the angles. You can also do this, the sides are congruent by saying these two and these two are congruent using that CPCTC. So there's a bunch of different ways that we can do this. It's super awesome that we can do it both ways, but that is how you would prove that a quadrilateral is a parallelogram. Again, what we want to make sure we refer to is one of these 5 options here. Either that both pairs of opposite sides are parallel, both pairs of opposite sides are congruent, both pairs of opposite angles are congruent, show that one pair of both is both congruent and parallel when it comes to the sides, or show that the diagonals bisect one another. If we can show one of those 5 things, then we have shown that any quadrilateral is a parallelogram. If you have any questions, feel free to reach out.